This video is about petrochemicals. In this chapter, you will find out about fossil fuel, the formation and fractional distillation of petroleum or crude oil, catalytic cracking, alternative transport fuels, biogas, addition polymerization, condensation polymerization, the disposal and recycling of plastic waste, biological condensation polymers, proteins, and carbohydrates. The new type of carbon is graphene and carbon nanotube. In graphene and carbon nanotube, carbon atoms arranged in a hexagonal pattern. In this part, we want to discuss about fossil fuel. There are three types of fossil fuel. The first is coal, and then petroleum or crude oil and natural gas. Anyone knows how petroleum is formed? Yes, from dead marine creatures that sank to the seabed and were covered by mud. The change into petroleum and natural gas was brought by high pressure, high temperature, and bacteria acting over millions of years. Oil fields and gas fields are detected by a series of geological and seismic surveys. Then promising areas drilled to gain more information. Once the field is established, production oil rigs can be set up and on land or at sea. Fractional distillation. Petroleum is a mixture of hydrocarbons. It is separated by fractional distillation using a fractionating column or tower. At the start, heated to 350 until 400 degrees Celsius and pumped in at the base of the tower. As it boils, the vapor passes up the tower. It passes through a series of bubble caps and cools as it rises further the column. Various petroleum fractions. The different fractions cool and condense at different temperatures and therefore at different height in the column. The fractions condensing at the different levels are collected on trays. Here, we pump petroleum or crude oil at the base of the tower and then heat up, and then the fraction will boil. The first we have refinery gas, and then around 40 degrees Celsius gasoline or petrol we use as fuel in cars, and then around 110 degrees Celsius we get naphtha used to make chemicals. 180 degrees Celsius we have kerosene or paraffin used as a fuel in jet engines and as heating oil. 260 degrees Celsius diesel oil used as a fuel in diesel engines, fuel oil, and then lubricating oil used in wax and polishes. 340 degrees Celsius we get bitumen or asphalt. The more number of carbon in the carbon chains, the higher the boiling point. The first we get from the fractionating column is refinery gas that contain 1 to 4 carbon atoms in the carbon chains of the hydrocarbons. Then the boiling point below 25 degrees Celsius. Continue with gasoline or petrol. The number of carbon atoms 4 until 12. Then the boiling point around 40 until 100 degrees Celsius. We get naphtha, then the number of carbon atoms 7 until 14, the boiling point 90 until 150, kerosene or paraffin 12 until 16, the boiling point 150 until 240, and we get diesel oil or gas oil 14 until 18, the boiling point 220 until 300, fuel oil 19 until 25, the carbon atoms, and then the boiling point 250 until 320, lubricating oil, here the carbon change long 20 until 40, so the boiling point also high 300 until 350 degrees Celsius, and the last is bitumen, the boiling point above 350, so this will stay at the base of the tower. The number of carbon atom over 70. There is a term you should know in this topic, that is catalytic cracking. In catalytic cracking, larger molecules from heavier fractions are broken down into smaller and more valuable molecules. It takes place in a huge reactor. Particles of catalyst made of powdered minerals such as silica, alumina, or zeolites are mixed with the hydrocarbons fraction at temperature around 500 degrees Celsius. The certain hydrocarbon molecules are produced by the type of the reaction, a shorter alkane and short alkene, or short alkene and short alkene and hydrogen. So from alkane to shorter alkane and short alkene, or alkane to short alkene plus short alkene plus hydrogen. For example, here we have decane C10H22 in catalytic cracking produce octane and ethene C8H18 and C2H4. Then carbon, this is decane until 1, 2, 3, 4, 5, 6, 7, 8. So here C8H18 because no double bond. So this one is an alkane but shorter. And then ethene C2H4. Important products can be made from the ethene produced by catalytic cracking. For example, here we have ethanol from the reaction of ethene with steam, ethene C2H4 plus H2O to form CH3 CH2OH, and then we have polymer from ethene, polyethylene by the reaction polymerization. And when ethene react with chlorine Cl2, we have phenyl chloride. Then the phenyl chloride can be polymerized into polychloroethene or PVC. Or ethene can be reacted with benzene to form phenylethene or styrene, then polymerized into polyphenylethene or polystyrene. Blending gasoline. Gasoline blending is a refinery operation that blends different component streams into various grades of gasoline. Typical grades include 83 octane, blended rather with an oxygenated fuel such as ethanol, regular 87 octane, and premium 92 octane. Alternative fuels and energy sources: diesel, gasoline from methanol, LPG and CNG, biofuels, and biogas. There is an effect of the usage of fuel from petroleum, that is greenhouse effect. Greenhouse effect is a natural process that warms the Earth's surface. When the sun's energy reaches the Earth's atmosphere, some of it is reflected back to space and the rest is absorbed and re-radiated by greenhouse gases.